Writing Lewis structures of nitric acid, HNO3. We start off identifying number of electrons. We've got 3 for each of the oxygens, 6 for each of the oxygens, 3 oxygens, 18 electrons, 5 for the nitrogen, 1 for the hydrogen. That'd be 24 electrons, or 12 pair. Nitrogen is a central atom. Each oxygen is attached onto a nitrogen, and the hydrogen is attached onto an oxygen. So that is the layout of nitric acids, the layout of our oxyacids in general. For our oxyacids in general, the oxygen is attached onto the central atom, the hydrogens are attached onto the oxygen. We've used 4 pairs of electrons, so let's start putting in more pairs of electrons. 5, 6, 7, 8, 9, 10, 11, 12. So we've used up all our electrons, but we're missing a pair on the nitrogen. So to complete the pair, we're going to steal one off the oxygen, make a double bond. So now the nitrogen has its 8 electrons. Everything else is a complete octet. Hydrogen only gets 1 pair of electrons. So we want to also do formal charge. So for hydrogen, we have 1 valence electron, 2 bonding electrons, we get half of that, so 1 bonding electron, 1 assigned electron, so a formal charge of 0. We have 2 different oxygens, one with a double bond, one with a single bond. Oxygen with a double bond, we're going to have 6 valence electrons minus our 4 non-bonding electrons. So we have 2 bonds, that's 4 electrons, we get half of that, so we have 2 bonding electrons. So the double bonded oxygen has a 0 formal charge. Oxygen with a single bond, 6 valence electrons, minus 6 non-bonding electrons, 1 bond with 2 electrons, we get half of that, so plus 1. So 6 minus 7, or negative 1 charge. So this oxygen over here has a minus 1 charge on it. The nitrogen, we start off with 5 valence electrons. We have 4 bonds, 8 electrons. We get half of that, or 4. So the nitrogen has a positive 1 charge. Can we reduce this formal charge and make a better formal charge setup? One of the ways to do that would be move a pair, non-bonding pair, from the oxygen into the bond, but that would exceed the octet on nitrogen. We cannot exceed the octet on nitrogen since it's a period 2 element. So this is the best structure we can draw. Lewis structure for Br3 minus 1. We have 3 times 7 is 21, plus 1 for the charge, so 22 electrons, or 11 pair. So we're going to use 3 bromines in a line. One is a central element. That use a 2 pair, so we keep filling up. So 3, 4, 5, 6, 7, 8, 9, 10. We have filled up all the octets, but we still have 1 more pair of electrons to use. What we're going to do in this case, where we have too many electrons, is we're going to put it on the central atom. So this bromine is going to get another pair. This can only occur if we're period 3, period 4, period 5, a higher period number, not period 2. So we have exceeded the octet on the bromine, but we're allowed to exceed the octet on the bromine since it has d orbitals it can access. So this is our structure for bromine, except to complete it, make sure that everyone knows we counted our electrons correctly. We're going to put square brackets on it and the charge. We should tell other people that we counted our electrons correctly.